We'll be starting with myself, and I'll be giving a bit of an overview of the learnings that we have had from the Smart Vehicle project over the past 2 years, and sort of where we've come from in the project and where we're going, because it's changed a little bit. Then we'll hear a little bit from my colleague Addie about our Route I modeling tool, and then we'll transfer over to hear a voice from UITP and some of the work that they're doing in the smart mobility space. So to get started, I'll give you a bit of an overview with the Smart Vehicle project. It initially started out as a smart bus project, this idea that we were going to get an automated bus and put it into public transit fleets. But then after a series of 5 technical planning sessions with stakeholders and cities, we realized it was more realistic to start with an automated shuttle. And obviously at Q-Trick, what we're really focused on is standardizing the technology across different manufacturers for fleet procurements for the purposes of transit fleets. And so the 4 areas that we really settled on after the technical planning session was standardizing, number 1, the V2V and V2I, or vehicle-to-vehicle and vehicle-to-infrastructure communication systems. The second was on the fleet management system. The third was on cybersecurity. And the fourth was on automated electric charging systems. And when we first started the OEM working group sessions, I went to different cities, all in our consortium around the country, and said, who's interested in this type of a project of doing a first mile, last mile demonstration with one of these electric automated low-speed shuttles, as we call ELSAs. And we had cities all over the country putting their hands up. I think we had about 12 cities. I think it ballooned up to 15 at one point that said, yes, we're interested in this. We'd like to stay engaged in it. So onwards we went. We initially had one champion manufacturer to get there, who, as I mentioned, was not able to join us today, but they're headquartered in the Netherlands, and they got it. They got it from day one, the need for standardization, the understanding that a city would need these technologies to be standardized, or it never really could be used for transit applications. And then earlier this year, we had EasyMile and Navia join in as well, also as champions in this space who got it, who understood the need that these vehicles need to be interoperable, they need to be standardized so they can be deployed on a single route. So I want to touch on the 4 points that I mentioned about the 4 standardization areas and sort of the learnings that we've had here. So I'll first start with the communication systems, and you heard probably more than you wanted to yesterday about DSRC versus 5G systems, and the conclusion from there was that DSRC systems are available today. The modules are available today. It's a proven technology. That's what the Siemens roadside unit looks like. So we had the OmniAir Consortium on the stage yesterday. For those who weren't here, OmniAir Consortium is the body that certifies that these devices are compliant with this standard stack. It's 5 IEEE standards and 1 SAE standard, and it ensures that any manufacturer certified under the OmniAir Consortium is compliant with those standard stacks and can therefore interoperate. And there's no concerns about then proprietary communication systems in the DSRC realm. And one of those that I think is quite interesting is the SAE J2735, which is essentially a dictionary of 16 messages that communicates between the vehicle and the traffic light. And that's sort of the dictionary of messages, and that is what V2I communication is. V2V communication is 3 simple things: is position, direction, and speed. That's all that the vehicles are communicating to one another so they can know where the other vehicles are in real time. So kind of put a big checkbox on that one. We have that one solved. The next one we looked at was fleet management system. So right now, the way that these vehicles operate is typically the manufacturer will sell you or will sell an operator their vehicle, and then they'll also sell you or sell their operator their operating system or their fleet management system. So to get there has a system called TOMS, Navia has a system called Navia Lead, and EasyMile has a system called Easy Fleet. And so what we were interested in is how can these 3 systems feed into one central transit operating system? Is that possible so that a transit agency now doesn't need 3 additional operating systems? They can just use what they know and what they have. And the conclusion of that and the discussion around that was that yes, it is possible. So I'll put a check mark there through API. We talked about API a little bit yesterday, and theoretically these systems, all 3 of them, should be able to feed into a transit agency's existing operating system so that transit agency themselves never have to see any of these back-end systems. It's never been done before. There's never been a circumstance where multiple manufacturers' fleet management software have fed into a single operating system, which is probably why we want to do it. We always want to be the world's first in these innovative spaces, and this is exactly what we're trying to do here. Cybersecurity. This one I left as a big question mark. It's very inconclusive. There isn't one comprehensive cybersecurity standard that a manufacturer could adhere to that covers every possible cyber risk that there is out there. Considering these vehicles rely so heavily on different pieces of infrastructure, are communicating with other vehicles along the way, and might have a third-party operator and then a transit agency and a manufacturer, there really right now isn't a comprehensive conclusion on what sort of cybersecurity standard, what single cybersecurity standard, or what stack of cybersecurity standards could cover all of these areas. So I'd still leave this as a bit of an unknown from our perspective. Another unknown from our perspective is the automated electric charging systems. There's lots of them out there. There's all kinds of options that you have, from the overhead high-power charging systems that are used for electric buses. Those can also be used on these shuttles if the shuttle manufacturers redesign their vehicles to be compliant with that. There's all sorts of plug-in options that you have. You have low-power plug-in options. You have under-the-vehicle en-route opportunity charging options. You have wireless charging options. But right now in the electric automated shuttle world, there isn't a consensus in terms of which way to go like there is now in the electric bus domain. And right now, there isn't enough sales for the manufacturers, the way that there was in the electric bus domain, to incentivize the manufacturers to redesign their vehicles to be compliant with one system or the other. And some manufacturers, one of ours to get there, has a proprietary system, and they're not going to give that up until there's a business case for them to actually give that up and redesign their vehicle. So in terms of some of the feedback we heard, as I mentioned, we had all kinds of cities that were interested in the project, and then as we went along the way, a lot of cities kept saying, oh, in 6 months, oh, talk to me in the fall, a little bit later. The priorities right now, which is understandable, for a lot of transit agencies, number one is bus electrification. We had a lot of systems say all the resources are tied up in bus electrification right now, which, as we heard about yesterday, is incredibly resource intensive, and so is this. The second is we heard from a lot of transit agencies as well that their priority right now in this area is human-driven, on-demand shuttles to underserved areas. Areas that either don't have service, areas that either have bus services once every half hour, once every hour, but it's not sufficient for that area, or areas that have buses that just run empty all the time. So what their interest is in looking at smaller shuttles that are driven by a human, that are in an on-demand fashion, and figure out what that would look like with their existing fleet, with the idea that that would eventually become automated in the future. The other trend that we were seeing for a while, and what I've been harping about all day today, is pilot projects and short-term pilot projects that a lot of cities have been focused on, and I am just absolutely elated to hear that now the wind is blowing in the opposite direction. That's yesterday's news, and we're moving on and progressing past that. And so, as I mentioned, priorities of the future is the automation of those on-demand services once those are in place. And our next panel, which I'm super excited about, is going to talk about some of these on-demand and hybrid transit models that are emerging that are examples of this. And then the last is, I think, further down the line, is the automation of buses on arterial routes. As we heard as well, the technology isn't quite there yet to stick it on a bus and put that bus into service the way that it is today. And I don't know if it ever will be. It'll likely be buses in dedicated laneways with this technology. So I wanted to raise 3 last points before I conclude here. This is a big one that I don't think is spoken a lot about, and it's something that I tried to bring up yesterday. It's all about the infrastructure ownership, maintenance, and usage for these vehicles. So there's 2 sides of this. One is the connected vehicle communication systems. So we talked about it once again a bit yesterday. There's these 2 competing systems, DSRC, or cellular V2X, which is, I guess we didn't explain all the acronyms yesterday, but cellular vehicle to everything. X is your variable, fill in there whatever you want. So those are these 2 systems we're looking at. DSRC is here today. CV2X is still in its infancy, and it's not nearly as developed, and it's going to be using the 5G LTE network once that becomes available, but it's not available today. So if you're a city and you're deciding, okay, we want to put connected vehicles out on our street, we want to start connecting our intersections, if you buy DSRC modules and invest in that, are they going to be obsolete in 2 or 5 years? It's a big question mark. It's a big uncertainty. On the flip side, if you wait, then when are you going to be able to get this technology? And as well, 5G, you're going to need a lot more 5G cell towers than we have 4G cell towers because their range isn't as big. So that's a huge investment. And who's going to be covering the costs of that? Is it going to be the traditional telecoms? We have other private sector players coming into this space. And as I mentioned, some cities are interested in putting up their own towers and then having other private sector players paying them to use those towers. So if you think about that from a city perspective, that's a lot to think about. Now if you add in automated vehicle localization and navigation system, this adds a whole other layer of complexity that frankly isn't ever spoken about at any conferences I go to. So different automators, autonomous manufacturers use different systems for their localization and navigation. Some use HD mapping, which means that you have to get a very high quality and accurate HD map on the street at all times, which has to be fairly regularly updated, because if you move a bench or if you move a mailbox or if a garbage can gets knocked over, and we've heard stories about the vehicles being as sensitive as HD mapping happening at nighttime when the flowers are curled up and the vehicle's fine, and then they deploy the vehicle during the day when the flowers are in full bloom and the vehicle doesn't move because it doesn't understand its environment and where it is. So there are sensitivities here, and who's going to be doing the HD mapping in a whole environment? Is each manufacturer doing their own HD mapping? Does that become redundant? Whose HD map does a city use? Other systems like EasyMile and Navio, who we heard from today, use RTK, which is real-time kinetic positioning. It's an increased accuracy in GPS, and a lot of systems use GNSS base stations. The downside of this is that GNSS base stations have a radius of 5 miles. So you need an antenna within every 5-mile radius where you deploy this. You also need line of sight to the antenna. So look at the picture of Toronto there. We have skyscrapers everywhere. You're going to need antennas everywhere to have line of sight to the roadway at any point. Magnetic markers, obviously physical infrastructure in the ground every 2 meters. Is that feasible for an entire city? And the last one is cameras. If it's cameras, then you need lines that are perfectly painted. You need signs that are perfect, that don't have a curved over edge or any kind of stickers on them where the vehicle might not be able to identify them. So if a city is looking at that, what is a city going to do? What part of that are they supposed to own? How do they trust, or how does anyone trust that the data that they're using, if they're getting it from a third party, is going to be accurate enough that there's not going to be any sort of safety considerations? And then how do we do this and not have streets that are just covered in loads of infrastructure, just loads of antennas and extra boxes and everything that we don't need right now in a crowded, urban, dense area? And there isn't really a conclusion about that, but I think that needs to be part of the dialogue moving forward. So I'll talk on this one quickly because I'm already out of time. So right now, drop my bottle. Right now, regulations favor auto, and we were talking about, and this isn't intentional, we were talking about the motor vehicle safety standards earlier, and if you look at a Waymo vehicle, they're using a Chrysler Pacifica, which is crash tested. It adheres to all the motor vehicle safety standards. It has its steering wheel, its brakes, its mirrors, everything that you need. These shuttles, as you see an example of it there, don't look anything like that, and it's going to take a while to change those motor vehicle safety standards, and these vehicles will be able to operate on the streets a lot faster than these automated shuttles will. So my point here is that right now, all roads point to this. This is the future of automated vehicles. As we know, Uber, Lyft, Waymo, every ride-sharing TNC company, Ford's getting in the space, GM's getting in the space of wanting to offer some sort of ride-sharing service on top of these existing entities. And what does this mean in terms of best business for them? They're going to want to have empty vehicles everywhere and anywhere that they can pick up people as fast as possible. So now it comes back to the whole question of who owns the roads, and it's the municipality. And the only way to avoid this, pretty much 2 ways. Allocations of roadways is one. The second is road pricing. There's really no other mechanism to prevent a future like this where these TNCs will want to deploy large fleets of their vehicles. But are cities ready to understand that and to think about that? So I suppose my point here is that there's a lot of other priorities that are going on. There's a lot of steps to get to this technology, but I would certainly encourage and push cities to try to get a feel for this technology as soon as possible. And if that means partnering with a business park or an airport or university campus to get a shuttle on their property first, you can learn from it and then build out policies based on that. That is the step to take. As we heard about electric buses, you need to get your feet wet. You need to try the technology or you're not going to be able to understand it. So with that, I will stop talking now with my raspy, nasally voice here, and I will turn to my colleague, Addie, who's going to take us through some of our Route I capabilities and a project that was linked to our Smart Vehicle project.
Thanks, Christy. We spoke a lot about modeling yesterday. You heard a lot of transit agencies talk about modeling being the first step towards electrification. I just wanted to walk you guys through our Route I modeling tool and what it's capable of and how it can help you in your transition towards electrification. So the specific capabilities of our Route I modeling tool, there's a lot on that page, so I just thought I'd simplify it a little bit for you. We do predictive GHG modeling. We do it for 4 specific kind of vehicles. We do battery electric buses, fuel cell electric buses, electric low-speed automated shuttles. I hope I said that right, Christy. And also for diesel, CNG, and hybrid buses as well to provide comparison. All those points on the left that you see, they're all to help with alleviating range anxiety in terms of predicting the time to charge your e-bus, that calculate the actual electricity cost in your jurisdiction, predict state of charge, and predict predictive bus or AV shuttle energy consumption analysis. All of that to help with range anxiety, which is one of those things that is one of the major concerns for transit authorities who are moving towards electrification. All of the ones on the right, our other features that we also offer, the time for H2 fueling, the suitability of a route or a block, that's one of our important things. If you provide us with your route data or your block data, depending on if you operate one bus in multiple routes, we actually go through that route and figure out the suitability of that route for electrification to figure out if it's easy, medium, or difficult to electrify, so that we can figure out if we have to change that route if we're moving towards electrification or not. Apart from that, we also provide recommendations for battery electric buses versus fuel cell electric buses versus ELSAs for specific routes, and also charging and route schedule analysis and calculation of actual GHG reductions. So you might be asking how we do all of this in one tool. And well, we start with our GIS modeling, which our GIS wizards do with GTFS data. Don't ask me how they do it. I don't understand it, which is why I leave it all up to them. They take inputs from traffic scenarios, transit schedules, and route profiles, and they do the GIS modeling. From that, we move on to our load modeling from those inputs up there. From the load modeling, we move on to step 3, which is the bus modeling, and step 4, which is the charger modeling. We take all of that, and one of our modeling samples, which we did for the ELSAs that Christy just mentioned, we have all of those cities that we worked with for our ELSA modeling, and those are 2 specific examples that I just wanted to highlight. We did the Montreal Olympic ELSA study, and we also did one for Calgary, which I believe is to the Calgary Zoo. Right? I heard it's lovely. I haven't been yet. And we also did some modeling work for electric buses as well. Edmonton Transit being one of our newest projects that we've worked on that we're very proud of. It's a 23-kilometer route. Did I get that right, Yishan? He wanted me to make sure I mentioned that. 23-kilometer route. Apart from that, one of our biggest projects was TTC. We had Mike yesterday mention this project where our values match very closely with what they're seeing en route right now. And you can see a little bit of what I mentioned earlier, where the ease of electrification, we have those highlighted on that map, which route is easy to electrify, which route is medium, and which route is difficult. And one more that I just wanted up there to give you an idea. This is a project that we have with the Transit Authority in the US. I'm not at liberty to mention the name, but I just wanted to give you guys an idea of what the routes look like when we do model them. And these are some of the other transit authorities that we have worked with. With that, I don't want to take too much of your time. Thank you so much. And I just want to put my information up there. If you have any questions about our modeling tool, feel free to grab me at any point. If you have any technical questions, then we have Dr. Ishan Ghosh up there. He has a PhD, and he'll be much better qualified to actually answer your questions. Thank you so much, Christy.